Hello all, welcome back. So the objective of today's class is how to remember the excitation table or application table for the each and every flip-flop. So in the previous class we have discussed, right? We have discussed the how to draw the excitation table when you know the truth table operation, right? So actual procedure is that how to find out the excitation table is first we need to draw the truth table. With the help of the truth table we are going to find out the excitation table or application table. But now question is that why do we remember the excitation tables or application table without writing the truth table? Means we might be having the some scenario. For example, if you are learning this subject for exam point of view, right? So directly they might be asking draw the excitation table for the SR flip flop, right? So let it be this is 1 mark question or 2 mark question. So it means that again you cannot write the truth table from truth table to excitation table. This will take much time for 1 mark or 2 mark question. And one more thing, if you are designing something counters, it is comes in the 5th unit where you will be having the synchronous counter, asynchronous counter design, where we need to draw the excitation table directly for the given flip flop, right? So or if you want to have next topic is something called as the flip flop conversions, where flip flop conversion directly we need to write the excitation table. So in that case, to find out the excitation table, again we should not write the truth table operation. It means that it is time consuming process if you are doing the same procedure. So try to do one thing is that if you remember this one, it means that without requirement of the truth table, so directly we can find out the excitation table output value, right? There is no concept behind here, just I'm giving the one method to remember those values, right? This is not the actual procedure, but just I'm giving some hint or idea to remember the excitation table without using the truth table, right? The actual procedure which I have explained in the previous classes, right? If you don't know, please go through that video so that you will be understanding how we can able to derive the excitation table with the help of the truth table. So in this today's class, without having the truth table, just I'm giving some shortcuts or logic, right? So by using that we can remember, right? So first if you consider here for excitation table means what is the input values? Always qn plus 1 are called as the input value. So what are the different flip flops we have? One is SR flip flop we have, another one is the JK flip flop we have, another one is D flip flop we have, another one is the T flip flop we have, right? So the inputs means these are the different kind of flip flop guys, right? So how many input possibilities? Either it may be 0 0, 0 1, 1 0, 1 1. So for this you need to find out the SR output, JK output, D output, T output. So in this class without using the truth table I am going to just giving the shortcut value, right? Now first we will complete the SR value. So this is S value, this is R value, right? So whatever we are discussing, everything is in terms of the digital system, right? So digital means representation of the binary number, right? So what is the binary number? We have 2-bit representation. What is there? It may be 0 or 1, right? So just to write here 0 1. So once binary sequence is completed, again what is the binary number start with the 0. Just to write the 0, right? So once it is done, so when S equal to 1, R equal to 1, if you remember SR flip flop truth table, what is this condition is called as invalid or indeterminate condition. So when this 1 1 means we are getting the invalid condition, right? Again I'm repeating, first binary number is 0, then 1, again repeat the 0, for S equal to 1, R equal to 1, the condition is the invalid condition, so that you can find the S value something like this. Now question is that how to write the R value. Just to flip the value, it means that what is this value will be writing this one. So last value will become the first value, then this value will be here, this value will be here, this value will be here, right? So what is the meaning? What I am trying to say here is just you write this value as the last value as the first value, before the last value is the second value is the third value, something like this, right? So see that what is this value? This value is the cross, right? This value is the cross, right? You just write here R value. So right, what is the meaning? This one is cross. What is the next value? 0, right? Just you write. And what is the next value? 1. What is the next value? 0. This is the SR flip flop excitation table. What is that? 0 1 0 cross, then this value cross 0 1 0, right? Now we'll complete for the JK flip flop, right? So again to start the binary number 0, then one more is the 1. So in case of SR flip flop we have single don't care condition. Just remember that here we have the two don't care conditions. Then how to write the k value? Just reverse, right? What is that value? Cross 1 0, that's it, right? So now come to D flip flop. What is the starting binary number? 0 1. Again you repeat the same step, 0 1, right? For T flip flop, you try to remember the truth table operation of the XOR logic gate, right? To try to remember the XOR logic gate. XOR logic gate, what is the output value? 0 1 1 0, right? So this is how we can remember the excitation table for the each and every flip flop without using the truth table operation, right? So this is one kind of logic which I know I am giving you. If you find any better option than this, you just try to post on the comments so that this can be useful for the remaining people also, right? Thank you very much, guys.